Get this, for the first time in over 50 years, we're actually going back. 4 people are about to strap themselves into the most powerful rocket ever built and aim for the moon. And you know, this is so much more than just another mission. It's really the start of a whole new chapter for humanity in space. So let's get into it and break down exactly why this flight is so incredibly historic. I mean, just let that sink in for a second. The last time anyone left the relative safety of low Earth orbit was all the way back in 1972. That means entire generations, maybe even you, have grown up never seeing humans venture out into deep space. Well, Artemis II is about to change all of that. You can think of this mission as the crucial bridge connecting the Apollo generation of the past with the Mars generation of the future.
So you might be wondering, hey, if we did this back in the 60s and 70s, why the huge 50-year gap? And why go back now? And that's a totally fair question. The short answer, the goal this time around is completely different. We're not just going back to plant a flag and grab some rocks.
Nope. This time, the plan is to stay. The whole point of the Artemis program is to figure out how to build a long-term human presence on the moon. It's about learning to live and work in that brutal deep space environment. So you see, the moon isn't really the final destination anymore. It's more like a training ground, a crucial stepping stone for the real next giant leap, sending astronauts to Mars. All right, so to pull something like this off, you're going to need some seriously impressive hardware. And for Artemis, NASA really went for it. We're talking a brand new rocket and a brand new spacecraft, built by combining all the hard-won lessons from the past with the absolute cutting-edge technology of today. Okay, meet the Space Launch System, or SLS. This thing is an absolute beast. At liftoff, it produces more sheer power than any rocket we've ever built. But what's really cool, I think, is its heritage. You see those 4 engines at the bottom? Those are veteran RS-25s. Yeah, the same kind that pushed the space shuttle into orbit. Some of these exact engines have been to space before. They've just been all shined up, upgraded, and are now ready for what's gotta be their most powerful ride yet. So the big question is, how does this new rocket stack up against the legend itself, the Saturn V from the Apollo missions? Well, this gives you a great side-by-side. As you can see, the SLS actually has more thrust at liftoff. It's got more muscle. But, and this is interesting, it actually carries less payload to the moon. And the reason for that is simple. It's a whole different mission philosophy. It's designed for a step-by-step approach to exploring the moon, not that one single massive all-in push that Apollo was. And what about the spacecraft the crew will be calling home? The Orion capsule, which, by the way, the crew named Integrity, is just a massive upgrade from the old Apollo command module. I mean, it fits 4 astronauts instead of 3. It has way more room inside. And instead of a million switches, it has a modern glass cockpit like a jetliner. And maybe most importantly, it has a toilet, a proper high-tech space toilet. Trust me, that's a luxury the Apollo guys would have been very, very jealous of. All right, you can't have a machine this amazing without an equally amazing crew. So let's meet the 4 pioneers who are going to be piloting this thing back to the moon. First up, in the commander's seat, we have Reid Wiseman. He's a U.S. Navy vet and a super experienced astronaut. He's already logged 165 days on the International Space Station. For this mission, the buck stops with him. He's the one responsible for the crew and for making all the tough calls. Flying as pilot is Victor Glover, another Navy captain and ISS veteran, and his role on this mission is just monumental. Think about this. For the very first time in human history, a person of color is going to travel beyond low Earth orbit. It's a huge historic moment. And the historic firsts just keep coming. Mission specialist Christina Koch is an electrical engineer, and get this, she already holds the record for the longest single spaceflight by a woman. We're talking a mind-blowing 328 days in space. Now, on Artemis II, she's set to become the first woman ever to fly to the moon. And rounding out this incredible international crew is mission specialist Jeremy Hansen from the Canadian Space Agency. And you're not going to believe this. This 10-day journey around the moon and back is his very first time in space. I mean, can you imagine? Talk about one heck of a rookie flight. So, what's the plan? What are these 4 actually going to do for 10 days? Well, it's definitely not just a joyride. Think of it more like the most intense test drive in human history. They need to push every single system on that Orion spacecraft to its limits before we even think about trying to land it on the moon. And those 10 days are going to be jam-packed. It all starts with that massive launch, but they don't head straight for the moon. First, they go into a special high Earth orbit to check everything out. Then on day 2, they hit the gas, lighting the engine for what's called the translunar injection burn. That's the point of no return. By day 4, they'll officially be farther from Earth than any human has ever been, breaking the record set by Apollo 13. Then on day 6, they'll do that iconic slingshot maneuver around the far side of the moon before heading back for a blazing fast reentry and a splashdown in the ocean. But one of the most important tests happens almost immediately after launch. The crew is going to take over manual control of Orion and basically practice flying it, using the big, empty upper stage of their rocket as a target. This is not just for fun. They have to prove, without a doubt, that they can fly this thing by hand, with incredible precision. Why? Because that exact skill could be the difference between life and death on a future mission, when they need to dock with a lander in lunar orbit. Now, all of this is incredibly exciting, but we also have to be real about it. Venturing into deep space is dangerous, period. And the Artemis II crew is facing risks that no human has had to deal with for half a century. And let's not mince words here. We need to be clear about what's at stake. A NASA report stated that the agency's acceptable risk for operations on the moon is a 1 in 30 chance of losing the crew. 1 in 30. Now, this mission is just a flyby, but that number really drives home just how dangerous and unforgiving this whole endeavor is. And the specific challenges they're facing are just immense. First, there's the heat shield. On the uncrewed test flight, it showed some weird, unexpected damage. So NASA's solution is to have them re-enter the atmosphere at an even steeper and faster angle, literally the fastest re-entry a crew has ever attempted. Then there's radiation. For the first time in 50 years, these astronauts will be completely outside the protection of Earth's magnetic field. And maybe the scariest part? Once they light that engine and commit to the moon, that's it. They are completely on their own. There is no way to rescue them. So why? Why take on all this risk? The answer is because Artemis II is so much more than just a single mission. It's the essential first step in a much, much bigger plan for our future out there in the cosmos. I think the crew put it perfectly. They said they're in a relay race. For them, this mission isn't the finish line. It's about successfully passing the baton to the next crew and the one after that. Their success is all about enabling the success of future missions. It's this incredible team effort that spans across generations. And here's how that relay race plays out. Step 1 is Artemis II. This mission, it's the big test. If it goes well, it greenlights Artemis III, the mission that will finally put humans, including the first woman, back on the surface of the moon. And from there, we start building a permanent lunar base, learning everything we need to know to take that ultimate giant leap, sending the first humans to Mars. So you see, Artemis II is the test. Artemis III will be the landing. This mission is about so much more than just 4 people flying around the moon. It's about reigniting that spirit of exploration that's deep inside all of us. It's a test of our technology, yes, but it's also a test of our courage and our vision for the future. So when we watch that rocket lift off, we're not just watching a launch. We are watching the very first move in humanity's grand return to the stars.